The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Well, I don't have a lecture, so good.
I have a random question.
Great.
So you've been a teacher for a very long time. Have you noticed any patterns in the students over the years or decades?
Have I noticed any pattern in students?
Yeah, or intellectual patterns or things that people are interested in, just anything.
Well, a few. The foreigners seem better educated than the Americans. There are more girls. When I came to MIT, it was about 20%, and I think now it's 53%. Does anyone know? What? 48? I read that it actually went past 50 for a few minutes. No, I think I've complained about the future, though, which is that a large proportion of my students, by students I mean the ones whose thesis I hate to say supervised, because in the case of Pat Winston, for example, I learned much more than or Sussman. But most of the students became researchers or faculty members eventually, and now very few of them do. That's I'm not sure of all the reasons, but in the 1960s, which is a long time ago, the universities were still growing as a after effect of World War II, I suppose. I really don't know what caused these major trends, but there were also a lot of career research institutions that were large and growing. Even General Motors had places where there was some basic research. IBM was a big research laboratory that was supporting some very abstract and basic research of various sorts. I don't think there's very much of that now. Even CBS laboratory. Westinghouse was doing interesting robotics, and of course Stanford Research Institute, which had no relation to Stanford, still exists, and it's still pretty good, but in those early days it was one of the 3 or 4 richest computer science and artificial intelligence research places. There was a place called the Rand Corporation, which I think still exists. Does anybody?
Yeah.
I don't know what it does. Any idea?
They do government consulting sort of things, just in terms of like writing big reports.
Mm-hmm.
Basically war games, but not necessarily about war, sort of economy games or politics games.
But in the 60s, it had a lot of basic research. It had Newell and Simon and me and a few other people, and we just went there and you could walk on the beach in Santa Monica and go to your office and talk and do things, and no one ever bothered us, and we wrote lots of little papers. And anyway, grumble, grumble. Another feature was that places like the National Institute of Health had 5-year fellowships, and now you have to renew. There are very few appointments of that sort anywhere, and usually you're no sooner do you get funded than you're starting to write proposals for the next year, and some people want reports every quarter, and Neil Gershenfeld, who was running a big lab here, wanted reports every month, and some of us finally gave up on that. That's a long answer, but so if you want a career in being a professor, it's just harder to find now than it was then. And so a lot of people recognize this pretty early and find some place to work in Wall Street and stuff like that. There are lots of jobs for smart people, but then you have to sneak your research in on the side. Anybody can think of a way to fix it? In the last 20 years, Taiwan made 100 new math departments, I read somewhere. I don't know if any of you know anything about Taiwan. I just wonder if that... Yes, were they successful? Is there a lot of research there? No. Very often when a government decides on the right thing to do, it doesn't work because I had some friends in Italy who were trying to start an AI group, and they had accumulated a critical mass in, what's the big city in the north? Milan. And then some government committee said, oh, there's some bunch of computer scientists there, but there's no good computer scientists in Pisa and Verona. So the government can order a professor to leave one place and go somewhere else. So the next year there were no groups. And occasionally there are people like Isaac Newton who like to work alone. But I got the impression that the product of the Italian researchers diminished after that. Might be wrong. How about a more technical question? Thanks.
Last week you had a complicated diagram concerning story. Do you recall the many layers?
Yeah.
Was that meant to be a bidirectional diagram? Does it work from the bottom up as well as the top down?
I'm confused about whether that, let's see if I can find it. Why did this shut down? Do I dare press start? Oh my gosh. I never saw that phenomenon before. Yeah, I can. What? Did it go on?
It's a strange person.
Oh, it's up. Oh, well. It might be in this random lecture. How do I get rid of those? Yes, there's a sort of bug in the toolbox thing on the Macintosh, which is if you make one of these too long, there's no way to get rid of it except to restart the machine in some other mode. I can't catch it. Anyway, maybe this works. Oh well, that diagram. There's two hierarchical diagrams. The theme of the Emotion Machine book is mostly the 6 layers of instinctive built-in reactions, learned conditioned reactions, and going up to reflective and self-reflective and so on. And the other diagram starts out with just a neural net, and then things like K-lines, which are ways to organize groups of activities, and then frames and transframes. The transframe is a way of representing knowledge in terms of how an action affects a situation, or a particular situation, and an action produces a new one. And then a story is usually a chain of transframes. And of course, a meaningful story is one which I didn't have a level for. Good stories and useless stories. So somewhere at a very high level, we all have knowledge of if you're facing some sort of problem, what kind of strategy might be good for solving that kind of problem. And in that case, each layer is made of things in the lower layer, whereas in the society of mind hierarchy, each layer does different things that operates on the result of the other layers. So there's sort of, I guess if you look at any mechanism, you'll have a diagram of what the parts do and how they relate, and you'll have a diagram of, which isn't in the machinery, of what are the functions of the different sets of parts and how are those functions related. So that might be a bug in both books, that I drew the diagrams to look pretty similar, and it's a bad analogy. Yeah.
When looking at it struck me in terms of like it was a stimulus response model where if you put a story into it, beneath it were the interpretive mechanisms. But does it flow the other way? Is it generative from bottom to top as well?
Well, in some sense, this transframe says, here's a piece of knowledge which says, if you're in such a situation, this is a way to get to another situation. In the traditional behaviorist is a word for the class of generations of psychologists who try to explain behavior just in terms of reacting to situations. And that wasn't connected to, what am I trying to say? In the standard behaviorist models, which were sort of occupied most of psychology from the 19th century up to the 1950s, when modern cognitive psychology really started, you just looked at the animal as a collection of reactions. And then in cognitive psychology, you start to look at the animal as having goals and problems, and then some machinery is used to go from the way you describe your situation to generating a plan for what you're going to do about that. And then the plan ends up being made of little actions, of course. But before 1950, there were only a few psychologists who and philosophers, I should say, going all the way back to people like David Hume, and Spinoza, and maybe Immanuel Kant. They made up, if you read their stuff and ignore the, the philosophy, you see that there was a very slow progress over really 3 centuries of trying to get from logic, which sort of first appears around the time of Leibniz. When is Leibniz? 1650 or so? It's about around, yes. They never met, I believe. So a lot of philosophy has, I don't know how to describe the rest of it, but a lot of it is trying to make high-level theories of how thinking works. And it's, of course, mixed with all sorts of problems about why the world exists, and ethics, and what are good things to do and bad, and all sorts of mixed up things. And psychology doesn't appear, I don't think there's a name for that field until the 1880s or so. Who's the first psychologist you can think of?
William James.
William James is around 1890. There's a guy named Wundt in Austria, I think. Sigmund Freud starts publishing around 1890. Francis Galton in England is maybe the first recognizable psychologist. He has a big book called An Inquiry into Human Faculty, which makes good reading right now, because it has, each chapter is about a different aspect of what would be called modern cognitive psychology. How do people recognize things? What kinds of memory cues do you use to retrieve stuff? All sorts of sort of, they're like term papers, the chapters. Some little theory, and you'd say, I can do better than that, and indeed you could. But at that time, no one could. Yes?
I feel like psychology is just thinking about how people think, which I think people have been doing, Aristotle did it, a lot of.
Aristotle has more good ideas than, as far as I'm concerned, everyone else put together for the next 1,000 years. It's just very remarkable. And we don't know anything about that because there are no manuscripts. Anybody? There's that wonderful play by, who's the Italian? What? No, a recent one.
Dario Poe?
No.
Italo Calvino.
No, he's sort of contemporary. Oh well. Anyway, he has a play about searching for the lost. There's some record that Aristotle had a book of jokes, or rather a book. He has books on ethics and things like that, and there's a book about humor, which is lost. And most scholars think it's not important because if you look at the 10 existing books on Aristotle, I think there's about 10, allegedly by him. They're students' notes, and almost every subject appears in at least 2 of them anyway. So one conjecture is that there really isn't any very much lost from ancient times. Anyway, it's if you ever read books, you might as well read 1 or 2 of Aristotle's, because it's the translations, I'm told, are pretty good, and you can actually get ideas from it. Yes?
I don't know if you ever heard about the theory of Giulio Tonini.
Humberto Eco is the writer. Sorry. How does memory work? Something about your expression. Sorry.
Giulio Tonini, like he tries to explain consciousness, but you say that consciousness is a suitcase word. But I don't quite agree with his definition. But like basically his definition is that the more the information is integrated, the more conscious being is, and basically
The more information you have,
the more integrated the information is. So, for example, I don't know. He gives the example of a MacBook that has a lot of information that's not integrated. Like, it is not correlated, and so it's not very conscious. But,
that sounds like an important idea, and there ought to be a name for it.
yeah, it has a name. I think it's IDT. And this guy is like a neuroscientist and a psychologist. And like he sees some edge cases of like people that split the brain in half. And it seems that like both halves are kind of conscious. But like I don't agree because that people, they still have the information that's integrated, but it seems that they are not conscious. So there must be like some action into that information, even if it's passive or active. But it seems very interesting.
Well, which of my 30 features that go into that suitcase do they have? It doesn't make any sense to say something is conscious or not, does it? You just said it yourself, that that there's some degree of integration, perhaps.
Yeah, yeah.
But can you say what you mean by integration? You probably need to say 20 things, and many of them might be independent.
So
Here's an example of something. Many years ago, people in the 1950s and 60s, it was very popular to talk about the left and right brain. Have you heard people say, what's the difference between the left brain and the right brain?
Supposed to be creative versus rational.
Rational versus emotional? Or... Now, I haven't heard anybody discuss that for the last 15 or 20 years.
Although it seems to have become really enmeshed in popular culture now. Like if you ask anybody what they know about the brain, one of the first things they'll say is, well, I'm more of a right brain person or a left brain person. That seems to be a sticking thing.
They used to, but I haven't heard that for at least 15 years. I have not heard a single psychologist mention it. Have you?
I think fMRI has all but obsoleted that theory. There's one thing it's good for. It's disproving that.
Anyway, I mentioned in the Society of Mind, I think I had a grumble about it, which is that, as far as I can tell, it appears to be true that language is located in most people in two very definite areas in the left brain, but occasionally in the right brain of some people. But other than that, as far as I can see, when you actually catalog the differences that the psychologists reported in the 1960s and 70s, then the things in the left brain were largely adult kinds of thinking, and the things in the right brain were largely childish. It wasn't that they were rational or not, it was that they weren't very hierarchical and tower-like. And I think there was a nice romantic idea of contrasting emotions and intellect and all those dumbbell distinctions and projecting them onto the brain. But I don't know what started me on that track. But it's interesting that it was very, very popular, and psychologists talked about it all the time when I was a student. And I haven't seen it mentioned by any cognitive psychologist for. Yeah.
And so, like, he mentioned history, but I believe we don't test our theory with edge cases. So, like, mental ill people, or like, I don't know, people that, probably there are a lot of people that, like, not a lot, but some percentage of people that are mentally ill, or like, don't have, I don't know, didn't form so well in some part of the brain. And maybe we can have some idea of, like, I don't know, what consciousness is, just by seeing, I don't know, people that don't have some part of the brain that might interfere with, like, something, I don't know. That like, the split brain may give a reason why, like, what's consciousness, because, like, maybe some half of brain, like, both halves are consciousness. And
Well, but I don't understand what you're trying to.
we study.
You're trying to construct a meaning for the word consciousness.
Well, Tononi is definitely onto something interesting, and I think the reason that he uses the word consciousness is that it's in the sense that people talk about losing or regaining it, and so that he can actually experimentally test his theory on people who are asleep or in a coma or dreaming or locked in or in a persistent vegetative state. And in each of those cases, his theory actually agrees with sort of the common sense idea of whether this person is conscious in a temporary way.
But then, is that different from if you use the word thinking instead? You could say when somebody's in a coma, they're not thinking, and when they're.
I don't think that it's good for him to use the word consciousness, and I think that the word consciousness to many people refers to a lot of things that his theory does not treat at all.
See, it's really dangerous if like, is it Pinker who likes consciousness? I forget.
Yeah.
It's dangerous to feel sure that that there's something very important and a central mystery and what does he call it? The hard problem of psychology. And so here's a really very smart guy, Steven Pinker, and as far as I can see, he does nothing but harm to the people he talks to, because he gets them to do bad experiments and waste their time. So instead of trying to revive consciousness, it's worth considering that might be a very bad thing to do to yourself and other people. What problem are you trying to solve? Is there any way, or the problem of qualia, for example? Because the standard view, and this is something that still is a serious disease even today in philosophy, that is the idea that the redness of red things is a very fundamental thing. It's indivisible, it's not describable. It's like, to those philosophers, that's just important as who was the Greek, Democritus, was it? Who discovered atoms?
Yeah, Democritus.
The idea of atoms was an enormous breakthrough. Of course, it took 2,000 years before people realized that, yes, there are atoms, and they're not. They're actually complicated systems made of quarks and 5 or 10 other things. So now we don't have atoms anymore. But I think Pinker has the idea that red is irreducible, and you can't describe it. It's like the atom of thought, and these qualia are the fundamental problem of psychology. To me, it's exactly the opposite. Why do we have a word for it? When I say red, do you experience the same thing as anyone else who says red? And it seems to me that somebody who got sick after eating a tomato has a different qualia for red, and blood, violent things, bad. Maybe another child has all sorts of pleasant associations with things that are red. And the concept of red is, it's not that it's inexpressible because it's indivisible. It's inexpressible because it's connected with thousands of other ideas and experiences. And therefore, there's no way to make a compact definition of it. But it's exactly the opposite. It's not the hard problem of psychology. It's not a problem of, it's something that will fall out automatically without any effort when you have a pretty good theory of psychology.
But why do we have this qualia of things like?
Why do we have descriptions of things? Because the animals that don't have compact descriptions of things get eaten very quickly because they can't recognize things that might hurt them. I mean, it's very important to have machinery for recognizing real things, and real things have features. In fact, there is such a thing as redness, namely the frequencies of light of around 400 nanometers. What's the frequency?
700 nanometers.
What?
Other end, 700 nanometers.
That far? That's infrared, isn't it?
A little bit.
Okay.
650, 680.
Anyway. One of the things somebody pointed out to me in later life is that there's only one yellow. There are a lot of shades of red, but interesting how tiny the yellow spectrum is. I don't know what it means. If you look around a room, I don't see a single one.
If you saw one, it might be a lion.
Is there what?
It might be a lion.
Oh, a lion. Yes, does anybody see anything yellow in here?
It's apparently really hard to generate the frequency of yellow light, and when you do it, you can make a lot of money.
Yes, what element has a bright yellow line?
Sodium.
Sodium. It's, yeah, orangish.
It's orange, yeah.
Yellow is the sun.
Yes, maybe that's very important.
Probably.
There's yellow chalk in the bin.
Yeah, that's right.
It's in the bin. That's great.
These lights are very
So this color is called warm white.
It was very yellow on
In the store,
You have
yeah.
a qualia ornament.
Warm white.
Warm white.
What is it in Finland?
I don't know. It's called the light like that, which comes from the tungsten, the awful outlawed tungsten light bulbs, which are not tungsten anymore.
Yes, that's right.
Are not anymore.
I've stocked up on 20-watt tungsten bulbs because my house is full of fluorescent bulbs that are remote controlled by things. And if there's no incandescent bulb in one of the sockets, then the remote controller breaks. These are the things you buy with, what are they called? Little units that
X10?
X10, right. The old X10 units are, the receivers burn out if there's no resistive load on them. So I have to have enough incandescent bulbs for the next 20 years or get rid of the X10s. I think they're illegal in Japan, aren't?
In Japan, they're still okay.
They're still there?
Yeah. You can still find them in some shops, and people buy them, so that because you can sell new ones that are allowed somewhere else.
I bought a lot of LED light bulbs at the Swap Fest the other day. Back to AI.
So in the reading, you seem to imply that evolution is a bad strategy for creating AI because, one, it'll take a lot of time, and two, because it'll get stuck in local minima and maxima. But if we had infinite time and enough mutation, do you think it would be possible to create a good artificial intelligence using evolution?
Well, if there's somebody in charge, if you have evolution like on a big planet, then you get a lot of life forms. And so the problem is that you might have some really stupid life form that eats the smart ones. So, but I have a more serious objection to evolution. See, there have been several projects in the last, well, since computer science started, of trying to make problem solvers smart by imitating evolution, which is variation and selection. So I know of about 5 or 6 such projects which were fairly well-funded and serious. The most interesting maybe was the one of Doug Lennett's, which was just him by himself. So if you look up Douglas Lennett's thesis, which was called, I forgot the name, AM, Automated Mathematician, and a second publication called EURISCO, E-U-R-I-S-K-O. Those were projects in which he did variation and selection, and he imitated chromosomes by having strings of simple operations, which were usually things like adding and subtracting and conditional jump and so forth. But there are several bugs with organic evolution, and the most serious one, which is that evolution doesn't remember what killed the losers. So there's no record in the genes of the mutations which were lethal. And in fact, it's almost the opposite. I'm told that in the human genome, I believe, is it still 90% doesn't do anything? Some large fraction.
Things they didn't think do something actually do stuff.
Well, they once did, presumably. About 90% of the human genome and a lot of other animals is not transcribed into proteins. And a fair amount of it is old inactive viruses. So it has, maybe 90% of some really deadly virus that got incorporated into the genome and gets copied. So the big bug in evolution to me is that if you're going to build a system that's going to try to develop a new kind of program by trial and error, the standard approach is to imitate Darwin, and you mutate these programs, you give them a test, and you then copy the programs that pass the test and repeat the cycle. So what happens is you collect, because you're mutating them as you go along, you're collecting genes that help solve problems, but you're not collecting information about genes that make the animal worse or make it fail to solve problems. So this is true of all of evolution as far as I can see, that there's no record kept of the worst things that can happen. And so every lethal mutation eventually kills someone. A lethal mutation is one, you have 2 copies of every gene, one from a mother and one from a father. And if you get 2 copies of the same gene, And most genes have a lot of genes are recessive in the sense that unless you get 2 of them, they're not expressed. If you have a lethal recessive gene, that usually means that you can have 1 of that gene and you're not sick, but if you have 2 of them, it eventually kills you. And it might kill you before birth, so that you don't even get an embryo, or it might kill you when you're 40 years old, as in that horrible Huntington's disease, where you can carry 1 and not suffer, but if you get 2, it kills you in middle age, which is very expensive for society. Anyway, there's no record. What you want to do is, for each problem solver that doesn't work, you want your evolution program to see why it doesn't work and not make that kind of gene again or whatever was responsible for it. So that's a big bug in Darwinian evolution. And the interesting fact is that every lethal recessive gene will eventually, on the average, kill someone. This is not a well-known. Do you see the arithmetic? Because it has to wait till there are 2 of them, and then it kills that person. And if you calculate the probabilities, that there's a half chance of getting each of them in each generation, the math shows that eventually there's 1 premature death for each recessive gene. It's kind of funny. So it would be nice if we had some way to clean them up once and for all, and then everybody would be a lot healthier. I bet within the next 20 or 30 years, we'll see some project which is to get rid of, just take somebody's genome, sweep out all the lethal recessives, and get rid of 100 diseases or more, and suddenly everybody will live to be 150 years instead of 100. Something like that ought to happen. Yeah.
There's some theories about why recessive genes stay in the population despite killing off people. And there's some genes for which it seems to be the case that, when you get 2 recessive genes, you die. But having the heterozygous combination gives you some benefit, gives you benefit against a different disease, and that's why they persist. So just getting rid of all of the recessive lethal genes might cause problems.
Wow, I hadn't thought of that. Are there some examples?
Sickle cell.
Yeah, malaria.
Yeah, sickle cell anemia. Malaria, so if you have sickle cell, you cannot get malaria.
Mm-hmm.
If you're heterozygous for the sickle cell disease,
But you don't. But that's not very beneficial because you usually die when you're around 40.
No. If you're heterozygous for sickle cell disease,
Oh.
then you don't have sickle cell disease, but you have benefits against malaria.
Oh, I didn't know that.
That's the example commonly given in all biology classes, but I'm sure there must be other examples.
I never took a biology That's good.
Marvin?
So we could probably find one that we just have to tailor it a little bit.
Mm-hmm.
Yeah.
Yeah.
So the mosquitoes don't like it? Is that what it is? Or
It's just bad enough blood that the mosquitoes will ignore you, but not bad enough if you die.
I was wondering, does it keep the mosquito from biting you, or does it make the mosquito sick, or what? It's just, yeah.
Yeah, some stuff I've read about viruses, people changing their theory about viruses, and one thing is that, maybe in some sense we're symbiotic with viruses, in some sense, and that, like you say, the junk comes in the genome, and maybe some process later takes advantage of that. So one thought I had is, maybe the viruses are the things that remember what the losers, remember why the losers lost.
That's a good point. There's still lots of things we don't know and wrongly believe. With this synthetic life,
Also, just
there are 2 groups starting to make, maybe more. There are probably some secret groups trying to make them too.
Also, in some sense, like, you know, the bacteria that live in the human body weigh, you know, far more than you know, the cells that are really yours and so forth. And so, you know, they started to think that maybe the entire genome of all the bacteria that colonize you were also part of that equation in some way. So, you know, it could be that some of the genetic information in evolution is not kept in your own genome, but kept in all the organisms that are, you know, that live with you externally.
Yeah,
Is there
it's,
omics for that yet?
What?
Is there an omics for that?
Yes, there is. That somebody was trying to sequence the.
Bacteriomics?
Yeah, I forget what you, biologists, do you know what that's called?
how many
Somebody's
different,
trying to sequence every genome of everything that lives in your gut, and you know.
yeah, how many, I understand there are more bacterial cells than somatic cells by a factor of 100 or something, because bacteria are so small. But how many different bacteria infests a person? Is it hundreds or tens or thousands?
I guess that's what they're trying to find out.
Yeah.
So when you say like in evolution, it would be nice if we had like if we kept a reserve of like everything that went bad, and then you said, and then we could like analyze it to see what went wrong, right? But like, isn't it that when we're doing like, I don't know, evolution algorithms or anything with genetic like that, we don't have a clear idea of what helps and what doesn't help to solve the problem? So even though we have like the information of the solver that didn't work, like I feel that if we had a way to know what went wrong, then we would already have like information enough to know what is right and like, you know?
Oh, yes.
So how do you decide what went wrong?
I was thinking of a fairly high-level system, because when Leonard or Larry Fogel, that was another one of these learning by evolution systems. I'm not suggesting that we could make a simple evolution simulation that would think of reasons why it failed. So this would be a high-level one if you're writing a big AI program. For example, when you learn arithmetic, after a while you learn not to divide by 0. So what do we call negative knowledge? What are the common sense things? Is there a name for the things you should never do? Because
Well, when people talk about, you know, they search trees of possibilities, you prune the trees.
you prune the tree.
Right.
But, you know, we have rule-based systems, and they got very popular around 1980 and wiped out most of symbolic AI for a long time. But there aren't any rules that say don't do X. Not, are they ever? Do they have some?
Some managed grid systems have negative rules, sure. Yeah.
Okay, so the question is, when are they invoked? In a certain situation, turn off this bank of rules, maybe. So I'm not suggesting that you could make a very simple system do that, because, in fact, figuring out why this mutation was bad might be a very hard problem. But as you build smarter and smarter ones, then you want to put, well, what I called critics, or what, I don't know if Freud had a name for them. At some point you want to have prohibited actions, and in Sigmund Freud's early model of psychology, there was a place for things that you would go away from or not do, and these censors, he called them. And they never appeared in the main line of psychology. When they threw out Freud, who had a few bad ideas, they threw out all his good ideas, practically.
You might be pleased to hear that some of the monkey neuroscientists are starting to find some critics. And it's pretty hand-wavy stuff. as of now, but at least they're thinking about it. There's certain tasks where the monkey is cued to pay attention to one thing or another. Usually, I think it's color versus orientation, and what they found is that orientation has dominance. And so when the cue is telling the monkey that they have to ignore the orientation and pay attention to the color, the part of those neurons which are responsible for looking at the orientation are being actively inhibited by another group of neurons, which they're now calling a critic.
Are these in the same organ, or is it a little nearby nucleus that's inhibiting?
Nearby nucleus.
That's nice. So that would be a good place for. Is there a word for negative knowledge?
We call it negative knowledge.
It would have too many different senses, but advice not to take. So,
So this question would imply that there's a metric for intelligence, but is there a limit to intelligence? As in, is it possible to say one day we have this artificial intelligence that is the most intelligent possible being?
seems unlikely because presumably the survival value of a particular system depends on the world the thing is in. It might be that for all worlds above a certain complexity, maybe there are some overall strategies that are universally better than others or something. But measuring intelligence doesn't make any sense because I think you have to go the way Howard Gardner did and say, well, there's social intelligence and I don't know. Can anybody rattle off his list? What are his 8 ways of thinking? Just look up Howard Gardner. So amount of intelligence is clearly it's a useful intuitive idea that for any particular machine you could imagine another one that can do everything that one can do and more, but you're going to get a lattice, not an ordered thing, and the lattice won't. At some point, it'll start getting inconsistent, and this will be better than that one for this and not that. And
Gardner had about 9 different types of intelligences, according to his Wikipedia article. Logical, mathematical, spatial, linguistic, bodily, kinesthetic, musical, interpersonal, intrapersonal, naturalistic, and existential.
there you go. And if you take any one of those, when I was a mathematician, I was really good at topology, but not at algebra. And at some point, that stopped me from being even better at topology. So if you take any one of those, I think Howard wants to keep it simple, but I wonder if he has a sub-psychologist who's chopped up mathematics into the right. What are the right 8 feet? How many of you are bad at some kind of mathematics and know why?
Really bad at Fourier series, just because I don't like them.
I wonder what Newton would have thought about them. In my PhD thesis, I had it was mostly about neural networks, and there were some people who thought that you could put information, if you had a bunch of neurons in a circle, then you could put in a string of signals of different durations, and and store the bits in this circular thing. Because in World War II, there were no digital computer memories, but there were some computer-like things that stored signals in a tube of mercury with a speaker and a microphone, and it was possible to store a lot of information in sort of analog bits for a long time. But what you would do is you would have something that would regenerate them and synchronize them with the clock each time around. And I was trying to prove a theorem that given what we knew about the delay in neurons, if you stimulate a neuron very strongly, it reacts more quickly than if you just stimulate it a little bit above threshold, then it takes a longer time to fire. So I was trying to prove that in neural networks in something like a human brain, you couldn't store a lot of information in circular loops. And I kept having trouble proving that, and I ran into John Nash, who was another student a bit ahead of me, and he listened to me for a minute and he said, expanded in Fourier series. And after about 2 days, I figured out what he probably meant. And I proved this nice theorem, and it turned out it's also, and it had been discovered a long time ago, it was called a Lipschitz condition. And if you have a certain condition like this, then the information will go away. But if you don't, you can keep the information around for a very long time. So in this case, the proof showed that you couldn't store, unless you had a renormalizer or a clock somewhere, you couldn't store circular information in a mammalian brain very well. It's a nice example of something where one person had a different way of looking at it. Nash was pretty famous for his results in game theory, but I suspect he might have been responsible for 5 or 10 other things that he... Norbert Wiener had this habit of talking to a student, and he says, "What are you working on?" And the student would explain it, and Wiener said, "Oh, well, you just do this." And I was present at a meeting I was in the math department, where they had a meeting about who would tell Wiener not to do that anymore. Some student had, oh well, it's a true story. I wonder what else I've forgotten. Yes?
I'm curious, you say this could be updated with a clock. Is there any evidence to suggest that biologically one could or could not construct a clock?
There are lots of clocks. I suspect that if I had thought about it more, I would have, because I'm talking the middle 1950s, and people knew a lot about brain waves, and there are 3 or 4 fairly large synchronous activities in the brain, and I don't think anybody knows much about what they're for. Do you know? Have you heard any rumors of what is the delta wave for?
Well, actually, the monkey experiment I was just talking about relies on sort of assumption that the beta wave is for suppression and the alpha wave is for activation. And I think people are still sort of debating about the delta and theta waves.
Mm-hmm. The alpha wave, what's the 10 per second? I think that's the big one. And it goes away when you are thinking hard. That is, if you're not focusing much on anything, then it's a fairly nice regular 10 per second. And if anything gets your attention and you focus on it, then the alpha wave pretty much gets noisy and disappears, I think. I don't know what the others do. Is that correlated with any event?
The usual room shutting down.
I brought all this, but I decided not to use it anyway.
I think it's correlated with a certain period of time after the signal from the computer stops changing.
Oh, you mean it might wake up again?
No, it shuts down at the same time every class.
It's not always the same time.
It's usually at 8:30.
And he stopped using the computer early. Correlation implies causation.
I wonder if Steve Jobs had, this little thing has 2 batteries, and at one end there's a dot, and the other end there's a slot, which is for a screwdriver, but it's also the minus sign of the battery. It could have been plus, but
It's for, actually for a quarter.
what's that?
It's for a quarter, so you can put a coin in it.
Any coin, actually.
Yeah, so you don't actually need a screwdriver.
I don't have a coin.
But you do have a screwdriver.
Of course. It's usually one. It's somewhere. No tips. Good question, yeah.
Do you think artificial intelligence will ever be elected as a leader of a government?
In most science fiction stories, it doesn't give us a choice. The moon is a harsh mistress. That was Robert Heinlein, wasn't it? It had a really smart computer emerged from the internet on the moon. Yeah.
Yes. I was curious whether you have any ideas how we could attempt to determine the representations of information either people or animals use to solve problems. Clearly this is a crucial problem to intelligence, and lots of AI has gotten into various ways of representing information. But it would be really interesting to see how it's done, and I was wondering if you had ideas of how that could be tested.
That's wonderful. What are the cognitive psychologists doing about representations? Have you run across any?
They study reaction times, which I think are probably a very good way of trying to turn into representations.
Mm-hmm.
They don't have very good ways of studying that directly from experiments.
Yeah. Right, rule-based systems are still the... I haven't read a modern cognitive psychology. Has anybody read a modern cognitive psychology book? Do they have trance frames or scripts? What's happening in that realm? Try to remember what. I guess I've never seen any Winston-like diagrams in anything but AI, but there must be some somewhere. That's 1970. Who's taken a psychology course? Is that true? What's in it?
They talk about babies a lot nowadays.
Well, there's a little industry of trying to show that Piaget was wrong. Is that what they say about babies? When do babies get conservation of quantity or something?
Yeah, basically just go throughout the whole development stage and explain that. But I have not seen Winston in any of my psychology readings.
Well, there is a problem with the low resolution of brain scanning, so that if you can only tell when a square centimeter of brain is more active than another part, then it's hard to imagine how you could look for the representation of an arch as a block on top of two others. But you should be able to make a hypothesis about a representation and then design an experiment in which you show a picture of an arch and then quickly show a picture where there's a little space between so it's not being supported by, and blink those on and off and see if different kinds of changes in the representation cause different kinds of brain activity. But I suspect that most experiments on watching brain activity are from giving a stimulus and not a pair of quickly changing ones, maybe. So you want to find out what parts of the brain are activated when a certain kind of difference appears. And it shouldn't be hard to make such experiments, but my impression is that they don't do that so much as you show a certain face for a couple of seconds and then you show something else and you look to see if the activity moves somewhere. But if your resolution is low, maybe you should be putting in stimuli that change so that you're finding the response to the changes. It's just a...
So one of the problems is that there is a delay. You can with brainwaves, you can get one real-time reaction, but at the variety.
Yeah, it usually takes several seconds to get anything.
Quickly.
You have to do a...
Doing something, but you won't be able to tell it.
You'd have to repeat it many times, and I think it still takes several seconds to get any information, doesn't it? What's the... The first brainwave experiments were in the in the 1940s, and that Englishman Gray Wolter, who also made that first robot turtle and things like that. I was just reading some papers he wrote in the middle 1950s. They're not very illuminating about AI, but they show you what some people were thinking in the days before computer science. Yeah.
When you talk about in your book about neural networks and big machines that accumulate huge libraries of statistical data, use that they cannot develop much cleverness because they don't have because they don't have higher reflective levels. What are these higher reflective levels?
Well, that's thinking about what you were thinking a minute ago. You think something and then you say, that was a bad idea, why did I get that? Or, now I realize I didn't understand something. I've wasted 5 minutes because reflective thinking is just thinking about your recent thoughts. Maybe all thinking is any coherent train of thinking. Each thought is something about the previous thought, but it doesn't have the word I in it. You know, you say, why did I waste so much time? Why did I focus on this rather than that? What did that person say? Maybe I missed the point. Or maybe most of your thinking is, what did I just think? Maybe I missed the point. Yeah.
So here we often talk a lot about cognitive science and psychology, and I'm curious, how important do you think brain cognitive science and psychology are to the field of AI, and whether the right way of trying to build intelligent machines and understanding intelligence is through understanding what we've already seen, or it's playing around with computers and trying to make systems that solve the problems we want to solve?
I'm glad you asked that because I don't think it's very important, because I think we've got to the point where we know that people solve problems, and we all know how to think about how we solved some problems. We don't know the details of how we did it, but I think, if you look at what's been done in AI, it's more than clear enough where the present system stopped and where they fail, and we keep thinking of ways to fix them, and we get sidetracked because you get some idea and it's too hard to program, and somebody says use C++, and somebody else says, why don't you go back to Lisp, and I guess my answer is, I don't think we need desperately to know more about psychology, because we already have programs that are pretty good at things, and we can see where they get stuck. But it would be nice if there were a community out there helping us, because the AI groups are all alone, and they don't communicate very well with each other, and they're not very well supported. But I bet as we make machines smarter, the psychologists will pay more attention, and they'll come back and tell us better things, and eventually there'll be a real cognitive science. It's sort of like physics. Physics got very well with Newton and Galileo, and quantum mechanics. But now they have a great community, and when some serious problem comes up, somebody will spend $1 billion for a new accelerator or something. There's nothing like that in AI. If you say, why did the Newell-Simon general problem solver get stuck on the missionary and cannibals? Somebody should say, well, here's $1 billion. I know it's not enough, but maybe you can make it a little smarter. Nobody's offering this.
Two somewhat related questions. The first, since AI is mostly an engineering discipline, it's a question of how can we make machines that solve these problems that look intelligent. Do you think this is going to lead to a better understanding of intelligence, and how important do you think that is to this more, I guess, mostly scientific but also slightly philosophical question?
I think it's just an engineering question that there just isn't a way to get enough bright people to compete with each other to make better AI systems. It's anybody have a theory? You see, I'm speaking from the point of view, feeling that there hasn't been much progress in recent years, and maybe I'm wrong, and there's a lot of great stuff just ready to be exploited, but I don't see it.
I think we're kind of in a natural equilibrium of sorts where people are doing a lot of the work in terms of, for instance, tuning the parameters and choosing machine learning approximations in order to solve problems that there are incentives out there to solve. And in principle, if we had AI that was good, the AI would do that work instead of programmers having to tune parameters and figure out which algorithms are good for different problems. But as of now, the way the incentives are structured, it's going to take a big energy push to sort of get over the hump of actually creating the infrastructure that's necessary for that stuff to happen automatically.
Yeah, there are AI groups. There are a few people at Georgia Tech and Carnegie Mellon, although my impression is that they're mostly playing robot soccer or something. And so a lot of the people who are empowered to do the right thing are, I mean, look at Stanford. It's wonderful to make these self-driving cars, but I don't think a single thing has been learned from that. Maybe a little has been learned from the Watson thing, but
They won't give out their source code.
right, and if they did, I think they could read the Society of Mind that says, have a lot of different methods and find some way to integrate them. What's missing in the Society of Mind is better ideas on how to integrate them. And Watson might have some, but on the other hand, it might not. Maybe if it can end up with an answer that's one word, like a person or a sport, then it's done. And so it may be that we know it's at the lower levels, and we don't know what's at the higher levels, and maybe it's no good. On the other hand, maybe there are 10 very important ideas there, and you'd have to read that long paper and try to guess what they were. Do we have a spy in there? Are they telling us something?
I get little bits and pieces about it, yeah. I mean, I think it is kind of, I think the good news about that is it has made some progress, and it is kind of a society of models, and they have some supervisory processes that try to figure out which, actually, the most important thing they do is try to figure out which method are good for which kind of questions.
That would be good. So,
I would say that's
so they might have some good critics and selectors like things.
Yeah, so there's some of that, I think, in there. And I don't think there are a lot of very brand new techniques, but I think, there's probably some of that, yeah.
They fired their other AI group, but I don't think it was getting very far either. The one I mean, the Eric Muller and, no, he moved.
He
Right.
worked on the Watson.
No, I mean Doug Ryken's,
Doug Ryken, yeah.
Ryken's group.
It's Columbia.
It was doing more mathematical AI than heuristic AI. Any other company doing anything? What are the common sense groups in Korea and places like that?
Well, I'll find out in December when I go there.
Henry's going to visit some of them. The mysterious East. Yes.
So there has been, like, since a long time ago, say like from the debugger Badger Sussman, there has been like machines that are trying to build like a reflective layer, right? They have critics, and even though the idea died out in the 80s, but then there's still some machines, like maybe Watson has some critics, but at the like reflective layer, I feel like it does a lot of different things. So what do you think is missing from
I'm not sure what you're asking, but there is Pat Winston's group working on stories, and my impression is that that's making definite progress, and if he can integrate it with Henry Lieberman's kind of large common sense knowledge base, maybe something great will happen, but progress is a little bit slow. Jerry Sussman is still full of ideas, but he keeps teaching courses in physics. And he's out there fixing telescopes, and he's absolutely a prodigy. And now he's working on this theory of propagators, which he claims is relevant to AI, and I don't understand it yet. But
It's good.
what?
I swear.
I'd like to see it solve some interesting problem. But so we have a lot of resources here, but if you look at the world as a whole,
Yeah, for example, you talked about how we should combine the perception in the sense group with the rich common sense knowledge base, right? So I feel like doing that, we need like some newly invented like machinery.
yeah, to what extent is,
Well, if you would like to work on it, please come see me afterwards.
it's a very lively group. What's happening to Lennett's group? Is he just hiding, or is he?
No, I think Doug Leonard is, the site project, and it's been steadily growing. And I think one thing that, he had a very interesting article recently about using it for common sense for medical queries. So the Watson guys said that, they wanted to apply Watson to medicine, but I think Lennart had a really good article about applying it to medical queries. It was things like, so the doctors would ask things like, which operations, for some disease or something, had complications. And the system would have to understand what's a complication, right? And a complication is when things don't go right. So having a drug reaction could be a complication. Leaving a scalpel in the patient could be a complication. So you have to understand some of the ideas of, common sense ideas of what might be a complication or what might cause trouble, or those kind of things. And I thought that was, he did a very nice system for the Cleveland Clinic, and the doctors loved it, and they wrote about it in the Eye magazine. I thought that was a real success.
Oh, I haven't seen that. Dr. Leonard.
I think the problem is that the reason that you haven't heard a lot of applications for psych for so long is because they were funded, for decades by, three-letter agencies in the government. And I think they did actually quite good work for them, because otherwise the program would have continued for 25 years. But the problem is, when they do something good for, the secret agencies, nobody else finds out about it. It doesn't advance the field.
I have a great story about that, which is almost unbelievable, which is, I was at a meeting with Doug Leonard. This is a long time ago, when it was just starting. And this was in a building a block from the White House. And it had all these people from some agency about whether AI could help them with their problems. And somebody pulled out some slides and was about to give a lecture. And but the shelf that had the projector on it had hinges, and all the screws were missing on one side, and it fell down like this, and they fussed for a long time and couldn't get the projector to line up. And then I had this thing, and I took 3 screws out of, it had 3 hinges, and I took 3 screws out of here and put them in here and here and here, and then the shelf stayed up and the show went on. And, you know, it's like the joke about the, anyway. So they were astounded because I actually fixed this stupid thing. And I said, well, why didn't you? And they said, we asked maintenance 3 weeks ago and they never got around to it. And I said, this is the agency? And they said, yes. And then they said, but why did you have that thing with you?
Today we never get past the metal detector.
When I was a kid, I heard some story, oh, never mind, about when a car wheel rolls off, you take 1 screw from each of the other 3. So I was doing exactly that, and these agency people had never thought of doing it themselves. So what does it mean when you have a government run by people who can't fix a hinge? I once met a freshman who didn't know which way to turn a screw at MIT. How many of you have to try both? The left hand. Some rule, right?
Not do the righty tighty lefty loosey anymore?
Yeah.
Well, if you're screwing in at weird angles, like valve set pieces and stuff, it doesn't.
Yes, sometimes. That's right. Enough stories.
Are you sure?
So has he, oh, can you send us a pointer to that paper? Leonard's.
Oh, yeah, sure.
That would be nice. He's one of the great pioneers of AI.
I guess that's about like extracting a piece of knowledge from experience. I feel like this is something that's done like in the reflector layer even. That well, it could be done in all layers, but maybe it's probably done in the reflector layer. So how do you think it does that? I mean,
How do you retrieve your knowledge?
how do you turn an experience into a piece of, like, a rule used by the critics?
How do you learn from an experience?
Yeah.
You do something and then you get some knowledge, and where do you put it?
How do you put it? Like, how general do you make it? Or do you just try it? Do you group a lot of experiences and then do some sort of...
If we could answer that, we could all quit and go home. You're asking the central problem of how do you learn from experience and later retrieve how you learned? I just can't think of any way to answer that except write a whole book and then have everybody find out what's wrong with it. yeah, science is making the best mistakes. If you make a really good mistake, then somebody will fix it and you'll get progress. If you make a silly mistake, then nothing is gained.
Maybe we should have research into how to make better mistakes.
Well, how do you decide what to try? Yeah. That's my complaint about the probabilistic methods, because if there are a lot of, well, I talked about it the other day, if there are a lot of different aspects of the situation, like 100, then there's 2 to the 100th conditional probabilities to think about. And so probabilistic learning machines work wonderfully well on small problems where the search trees aren't too big, but they don't. But the hard problem is what to do when there's a lot of different factors and you don't know which are important. And in lots of situations, just first-order correlations. So if there are 100 factors and you just look at the probabilities of each of them, and then there's 5,000 pairs of things, and you look at the 5,000 joint conditional probabilities of 2 things, and maybe 5 of them pop up, and you've only got 5 things to look at, and that's where that kind of AI system works. And it's become immensely popular. And the trouble is it'll never get smarter, because if you have to look 5 steps ahead, then instead of 10 possibilities, you have 100,000. And anyway, my concern is that there are quite a lot of millions of dollars going into AI research, but most of it is going into dead ends. So it's not as though there weren't maybe there is enough money, but it's going to the easy problems instead of the hard ones. Who has an easy question?
I have an easy question. So a lot of smart people like to play games and procrastinate. Do you think artificial intelligence will also like to play games and procrastinate?
Well, there's the opposite question. I got a message from somebody, I don't remember who. I had complained that nobody's been able to get Push Singh's AI program to work. And somebody suggested, what? Yeah. And somebody suggested that, I forget the name, there's some group of people who like problems, and I can't remember it's just some bunch of people out on the web who like to solve programming problems. And this person suggested sending the code to that group of couple of thousand people, and maybe they would self-organize to try to figure out how it works and fix it. So, do you think could that work?
Yeah.
We have a big bunch of code, it's partly commented. Could we get 1,000 really aimless hackers out there with lots of ability to? So maybe I'll try it.
One of the danger with that is that they might add their own code or their own sections.
Well, if they're self-organizing enough, I mean, if an individual tries to fix it, that's fine. But maybe these people know how to work together, so they could chop it up and talk to each other and agree on. It doesn't have to be the same as pushes. It just has to, I don't know if you've seen the movie, I'll bring it next time. He had a robot coming to try to screw the legs onto a table, but the robot has only one hand. So there's another robot over there. The first one says help, and the other one figures out just enough to come over and pick up the other end of the table. So as far as I know, this thesis only worked out one example.
Yeah, actually it was, the trick part in that was that when the other robot said help, the other one was looking away. So yeah, you know this, but many people don't. So the other one turned there, and then at first the other robot incorrectly thought that the first robot is trying to take the table apart.
Yes.
So then you have the second robot doing that, and then you have to correct that no, and then you go back and you show that you're trying to fix it.
Right, and the first robot just says no, which the other robot has to be very stupid to be able to interpret that as exactly one thing not to do. If it were smarter, it probably wouldn't work. But anyway, I'll bring the movie and have you looked at the code?
Yeah, I have a little bit, although I haven't really tried to debug it myself.
It looks pretty hard.
Yeah, I probably have the movie. I probably have the movie on the machine if you want it.
My favorite story, which I think is true, is that Slagle's program for doing integration was about 5 pages of Lisp. And Joel Moses said that it took him several weeks to figure out, because Slagle was blind and had to program in Braille. So Joel said that he made the most intricate, convoluted expressions so that he wouldn't have to type so much. And then Joel, so that was the first, I had written a program that differentiated algebraic expressions. And that was a great breakthrough, although it was completely trivial. Namely, I just put in the letter D, and if it saw an expression x times y, it would say x dy times dy plus y times dx. And there are only 4 or 5 such rules. Then it just sweep through until it had this big long expression, and that turned out to be the derivative. But then Joel wrote, the trouble is it was too long, and then Moses wrote something to simplify it. And then Slagle wrote a simple integration program. And then Moses wrote a really complicated one. And eventually, a couple of other mathematicians studied that and extended it and worked out a theory of, for the final integration program that could integrate any expression that had an integral in closed algebraic form, which means a function of exponents, sines, and cosines, and polynomials. And the result of that was a sort of nice story, which is that the American Mathematical Society had a big suite of rooms in Providence, their headquarters, where they had collected all the integrals that were known for hundreds of years, ever since Newton did the first ones. And there were rooms full of, so every time somebody found a new integral, they would write it up and send it to the American Math Society, and it would get cataloged there, and they had raised funds for, it was called the Bateman manuscript copy, and there was a fund for organizing all this data. And the minute the program came out, the Bateman manuscript project was terminated and closed. Because, and I think Maxima had the solution in it, and Mathematica is the sort of big successor to that. But it was a nice piece of history spread over about 5 or 6 years. And I don't know that anybody works on that anymore. We had a couple of PhD theses starting of trying to solve differential equations, and they didn't get very far. That's probably important. Looks like Lemelson is over.
It's the 100K.
Elevator pitch.
Oh,
Do you think they actually awarded one?
Yeah,
probably.
they do every year. Every year is the
Well, they have 100K every year. I think the elevator pitch contest as a separate thing is newer.
Oh, there's 3 parts of it. The first one.
Well, any more?
One back.
Oh, way back.
Do you think there's ever going to be a way to like crowdsource AI research at all? Like
That's what I meant. That's the expression I was looking for fixing the push thesis, but it would be nice.
but it wouldn't be a self-organizing thing. Like someone would have to. I mean, because that I feel like that would not be. It would be hard for people to self-organize to like do that. But if there were already like a structure and like that minimal piece that like everyone could do for AI research was like already defined. Like, do you think AI research is like structured in a way that could ever be broken down like that?
Well, don't these crowd things usually start with they must start with some sort of leader, but then they become self-organizing, or?
I mean, they work because every participant has like a specific and distinct, has like basically the same small goal. And, you know, I mean, they don't become like more complex than that. I mean, it becomes like a community or whatever, but it doesn't, you know, like the idea of like lowering the floor of like doing AI like research so that more people can like contribute.
It's a nice question. Well, let's think about it. If we take this PhD thesis code, it wouldn't be much good to send the whole thing to everyone. Well, of course, it wouldn't cost anything to do that. But you need somebody to make a first pass at chopping it up into saying, look, this function didn't work. Maybe there's some code missing. And so you might need a person or a couple of people to sort of organize the project. But once you got a community, they might be able to cooperate. They might do without a leader once the problems became clear enough. Because
I would say that, I mean, there are some crowdsourced AI projects, certainly, if you go to SourceForge or the restaurant game of Jeff Morgan and Odd Lab, that's their crowdsourced. You can think of that as a crowdsourced AI problem. But I don't think the crowdsourcing is really great for problems that demand a lot of creativity. You know, it's commands that are, projects that are labor intensive, it's good for like SETI at home, that kind of thing. But for projects that demand a lot of creativity, and, you know, it kind of breaks my heart almost, because if you look at like the open source work on Unix, you know, they've done a great job in organizing people to work on Unix and free versions, you know, Linux and free versions of Unix. But on the other hand, you know, the software isn't very innovative. They just implement 60 versions of the mail program. The Unix interface hasn't changed since the 1960s, pretty much. So, everybody's still programming on terminal windows. So I think crowdsourcing is mainly good for projects that are labor intensive, but I think AI needs individual creativity more. It's like McCarthy said, it needs 2.3 Einsteins and 1.7 Manhattan projects. It's probably good for the Manhattan projects, but not for the Einsteins.
Mm-hmm. On the other hand, given we have the movie, it might be that the problem of getting this code to make that movie isn't so creative. You could find out, start it up and see where it gets stuck, and it's worth it.
Possibility is if you have something along the lines of Watson that incorporates lots and lots of small programs, then you can have people contribute small programs, and whether they're good or bad, the system can figure it out and reward them accordingly.
Well, in some sense, Watson was crowdsourced because it wasn't only developed by that IBM group, that they had lots of collaborators in ISI and CMU and other places, and they crowdsourced them by giving them little research grants to integrate their part of the research into Watson.
I see.
So I think you could argue that actually was crowdsourced.
Another thing we haven't tried is called throwing money at it.
Right.
Suppose we got $5,000 or $1,000 and told some programmer, can you get this to work?
Well, if you have good enough descriptions of various small programs that you would use for problem solving, then I think that part of the problem with creativity is solved, because some parts or some subprograms could be more stupid. And as long as you have a good description of what that program is doing, then you could have some really creative program that might use those stupid programs as parts of that.
But you still need
parts of its reasoning.
You still need that one really creative person to make the
some
really creative
people, but you don't need so many.
Right.
If you organize it in more detail.
Yeah.
I just labeled it World of Warcraft 10, leak it on the internet.
My grandson was suspended from Warcraft for 3 weeks because he hacked the thing to get a higher priority on something. I think he was not. Do you know how old he was? Yeah. No, Miles.
I don't think he's played one of those games in a long time.
No, I think he was about 10 or 12. And he had actually managed to get into the thing and get instant service. He was very proud of being banned. I give up. Any last request or idea? Thanks for coming.